Hello, class. Welcome to today's lesson. Today's lesson is going to be on a topic from section 1-2 in your textbook called difference quotients. A difference quotient is a special formula from calculus class. So what we learned to do this year is we learned to work with these difference quotients using our algebra skills. But unfortunately, this year in class, I won't be able to explain what these special formulas mean. But your calculus teacher will definitely tell you next year. So the difference quotient comes in many different forms. Here are 3 examples. You do not need to memorize these structures because anytime we want you to work with one of these formulas while you're in this class, we'll give you the formula. If you go take calculus next year, you'll have to memorize these different formulas, but when you understand what they mean, that'll be an easier task. So notice that each one has a difference. Subtraction, that's the difference, and notice each one is a quotient. So each one has a big fraction. Your function name might be f, your function name might be g. A lot of times we'll see h's, sometimes c's, or sometimes a k there. And sometimes we even get numbers. Like here I put a -3 in there, and I put a -3 in here as well. And that could be a different number in a different problem. It could be a 5 or 2 or 4.8, could be anything. So you don't need to memorize the structure. We're just going to learn how to work with them this year. All right, so let me move down so we can start our first example. And you want to copy that into your notebooks. And our first example is going to be using this particular version of the formula. I selected G for the function name. I'm using H, and I've selected 2 for a number in there. And I'm giving you a function. So all of that will be given this year. And the H not equal to 0, by the way, I forgot to mention that before. That's just there, just announcing, hey, remember, the denominator can't be 0. And we know that. All right, so even though we don't know what this formula actually represents yet, you won't learn till calculus, we can go ahead and evaluate that difference quotient now. So notice in this formula, there are 2 things that we need to find. There's g of 2 plus h and g of 2. This is the function g. If I ask you to find g of 2, let me do that over here. You know what that means. That means go to the function g and plug in 2. So we're going to be talking about 2 squared minus 7 times 2. And we work that out, we're going to get 18. Just kidding. We're going to end up with -10. I made a sign error there. Okay, so -10, because it's 4 minus 14, not 4 plus 14. So g of 2 is 10. That means anywhere you see g of 2, you can replace it with -10. Okay, now continuing on our way, we also need for this formula g of 2 plus h. I like to do this work over to the side. Some of you will decide to do the work right in here in the formula, and that's fine with me. But I prefer to do it off to the side because this is the trickiest part, in my opinion. So what we need to do to find g of 2 plus h is we need to go in here, and wherever there's an x, so here, here, and here, we need to replace all of those x's with 2 plus h. So here it says to square whatever you're plugging in. So I'm going to put 2 plus h here and square it. Then I copy the minus, I copy the 7, and then where I have an x, I'm going to replace with 2 plus h. So all you're doing is you're replacing x everywhere you see it with 2 plus h. Sometimes it helps to see it like this. So I'm just going to copy the original function right on top of this. So if you notice, I have it all lined up. So right here where you have instead of x, I'm using 2 plus h because that's what it says in the formula. And then here instead of x, I'm using 2 plus h, and here instead of x, I'm using 2 plus h. Now we work our algebra skills. So right here, when you square, please do not square the 2 and square the h. You will get a wrong answer. You need to do 2 plus h times 2 plus h. So you have to FOIL or double distribute. A lot of you will not need to write out this step. You'll be able to just go ahead and FOIL, and that's fine with me. When you do that, you're going to end up with 4 plus 4h plus h squared when you combine the outers and inners. Okay, now over here I have to distribute the -7. So it's -14 minus 7h. And then I get, when I combine all of this, and it doesn't have to be written in standard form, but I just kind of naturally put my h squared term first. And then when I combine the h's, I have a -3h, and then I have a -10 at the end. So that is the expression for g of 2 plus h. So what that means is wherever I see g of 2 plus h, I can replace it with these 3 terms. So now what we're going to do is we're going to go back to this formula. A lot of times, especially for beginners, I suggest rewriting the formula, and you guys are beginners with the formula. So I'm going to rewrite the formula that was given that we're not going to memorize. And then we're going to make those replacements. So in place of g of 2 plus h, we're going to put h squared minus 3h minus 10. And in place of g of 2, we're going to put a negative 10. So let's do that now. So this is equal to h squared. I decided to come down here. Of course, you can do your work horizontally. I just decided to drop down to the next line. So I have h squared minus 3h minus 10, the minus from the formula, and then a negative 10 for the value of g of 2. So there's a minus from the formula. Let me accentuate that. So there's a minus here in this formula. That's this minus right here. And then there's a negative on the value of g of 2. Okay. And then that whole thing is over h because that's the original formula that we were given. Now, the good news is you should always know if you are working out a difference quotient correctly, because if you're working it out correctly, terms should always cancel and terms should always reduce. So what's going to happen here is you see the minus the negative, that's going to become a plus 10. And here are the terms that cancel. So if you're doing this correctly, you should always have terms that cancel. If you recognize that in this step, you can cross out right there. And then please do a separate step for this one. Some of you see already that you're going to end up reducing these h's, but I would like a second step here because I want to make sure that I can see that you're actually canceling the 10s before you reduce the h. So when you go to reduce, you're going to end up with, I'm going to put that over here. You're going to end up with h minus 3. If you can do that in your head, that's fine. If you want, you can factor out an h and then reduce a pair of h over h's. Or another option, when you're at this step, a lot of students like to do what I call the pull apart here. You pull this apart into two terms. Uh-oh, hang on. Marker went crazy. Okay, so you take the first term of the numerator and put it over the denominator. And you can do this when you have a monomial denominator, when you have a one-term denominator. And then you can do minus 3h over h. And here, h squared over h reduces to just h to the first. And minus 3h over h becomes minus 3. Sometimes students think this part right here should become negative 2. That's incorrect. What you're doing here is this is like a 1h. So negative 3 over 1 is negative 3. And h over h reduces out because it becomes 1 over 1. So indeed, this is not minus 2h. This is just minus 3. And that's your first difference quotient. I am so sorry that this answer means nothing to you, but you will learn in calculus next year what it means. Okay, let's slide down to the next example. Let me clear my screen. And here's my next example. I have chosen for this one because that's example 1 again. Sneaky. Okay, let's do example 2 this time. All right, so example 2. I've chosen for this one to call the function f. I've chosen the version of the formula that uses an h, and I've made up this linear function for us. The last one was quadratic. This one's linear because if you were to graph that, that's just a line. So again, what I like to do is I like to do my work off to the side for figuring out these two pieces. That's where you start. You got to find those two pieces. Now, you actually have one of those already. You already know what f of x is. I really don't even have to write it because f of x is given. So this time, there's no work to do to find what I'm going to substitute in place of f of x. I'm going to substitute 5x plus 8. F of x plus h is going to have a little bit of work for us to do. So f of x plus h says go to function f, and wherever you see an x, replace that x with x plus h. So instead of x, I'm going to put x plus h. And after you distribute the 5, you'll get 5x plus 5h plus 8. And you can then replace f of x plus h with these three terms wherever you see it. Now, I'm going to take a time out here because this is the step where a lot of times students get thrown off. So I'm going to rewrite this in red just above. Okay, so we can kind of focus on this step. Because what a lot of students see is they see the x plus h, and they want to just put plus h on the end. And I'm sure some of you want to do that. So when you look at f of x plus h, what happens is a lot of students just want to throw a plus h on the end there, and that's going to give you an incorrect answer. That is not correct. Okay, so it's not just put an h at the end. What we're doing is we're replacing x everywhere we see it with x plus h. So in place of x, I put x plus h. In place of x, I put x plus h. Now, if that's still throwing you off a little bit, here's what I usually do in class, because usually there's a number of students in class who are still kind of thrown by that. So I totally get it. You're not alone. I guarantee there's a lot of people in the class right now saying, how did she get that? Okay. So for those of you who got it on the first try, just bear with me, please. Okay. So let me trick you into this. If our goal is to find f of x plus h, right? So if you're having any difficulty with that, to trick you into understanding why it just becomes this, what I usually ask in class is, okay, I say, do me a favor. This is f of x. Tell me what f of 2 would be. How would you get that? And then the student says, I would plug in 2 for x and work it out and get my answer. And then I'd say, okay, with that same function, tell me what f of a would be. And then the student would say, okay, I would plug in a instead of x, and that would be the expression I would get. Great. And then I say, usually in class, I say, okay, instead of f of x, let's find f of d plus c. And if I ask you to find f of d plus c, the student will say, oh, just put d plus c instead of x. Okay, so no matter what you have in here, you're just replacing x with that amount, whether it's a 2 or an a or d plus c. So if I have f of x equals 5x plus 8 is given, if I ask you to find f of x plus h, I'm just asking you to go in here and wherever you see the x, put x plus h instead. I hope that helped. It's much easier when we're together in class to have this discussion, but I'll find out in the Edpuzzle if that helped you out at all. Okay, so let's get back to our formula. You don't have to write this part down, but because that's for anybody who had a little bit of trouble understanding why this became the expression, why the x plus h went in here. Let me jump in here and I'm going to rewrite the formula. You will find this step unnecessary at some point, but for beginners, I do recommend it. And you don't have to put the h not equal to 0. That's given in the formula. That's fine. And what we want to do is we want to replace f of x plus h and replace f of x. And don't forget that there's going to be a minus sign in between. Okay, so f of x plus h is equal to these three terms. So I'm going to replace with 5x plus 5h plus 8. And then I have the minus sign. There's no reason for you to need to make that a different color. I'm making it a different color to accentuate that it's a minus there. And then we need to replace f of x. F of x is 5x plus 8. Or you can just look back to here. F of x was given. It's 5x plus 8. Okay. And that all goes over h. And what I have written is incorrect. When you have minus f of x, if you're replacing f of x with multiple terms, see how that's two terms? You have to distribute the negative. So if you're comfortable distributing the negative right away, that's fine. But for beginners, I recommend that you keep the minus and use parentheses. So if you're replacing this term with more than one term, you're going to have to distribute. And so those parentheses are necessary in that step. So now I have 5x plus 5h plus 8 minus 5x, and that's going to become minus 8. And that's good news, because remember what I said on the last one. If you're doing this correctly, terms will cancel, and then terms will reduce. So look up in here, what can cancel? Well, the 5x and the minus 5x, that becomes 0, and 8 minus 8 becomes 0. So if you're doing this correctly, things will cancel. And then please make this one a separate step. So 5h over h is all we have left, and that's going to reduce to 5. And that's your final answer. And again, I apologize. It doesn't mean anything to you right now, but it will next year. And notice if you look back at the previous answer had a letter and a number in it. And sometimes it's just a number. And sometimes it's going to be two numbers and two letters, or two letters and three numbers. So the answer can have different looks to it. I don't want you to think that it always looks exactly the same. So the last answer had a letter and a number. This one has just a number. Okay, I have one more for us today. And let me clear this out. Grab the mouse. And this is the one we're going to be looking at. So this time I used C instead of H, and I made up a quadratic for us. And in order to do this problem, we're going to need to find f of x plus c and f of x. So f of x is given. So as a matter of fact, if you wanted to, you could even put that in right now. So it's 3x squared minus 2 all over c. I'm going to grab a different color for that minus sign because I want to accentuate that there's a minus there. Because when you replace with two terms, you're going to have to distribute the negative. So what we still need to find is what this, I didn't want that color. What we still need to find, all right, I'm going to trace over it, is f of x plus c. We have to find out what this is and plug it in. So I'm going to do that over here, off to the side. Okay. So f of x plus c, well, if f of x is 3x squared minus 2, then what we're going to do is we're going to go in and replace x anywhere we see it, here and here, with that expression. So I'm going to keep the 3. I'm going to keep the 3. I'm going to be replacing x. I'm going to keep the squared, and I'm going to keep the minus 2. So all I'm going to do is instead of x, I'm going to put x plus c. Grab another color for that. How about that one? Okay. So I'm replacing x with x plus c. That's all we're doing. We're replacing x with x plus c. Okay, that's the tricky part. So if you are confused on that step right there, you can ask about it in class next time we meet, and I guarantee you're not alone. That's something we usually discuss a couple times in class. But let's go ahead and continue this example to review some algebra. So here, we, again, you can't just square the x and square the c. You have to FOIL x plus c times x plus c. Now, if anyone is thinking, could I distribute a 3 first? You can, but I don't recommend it. So you have 3 factors here. I have a 3, an x plus c, and x plus c. Whenever you have factors that look alike, I would multiply those together first. So these look alike, so I'm going to multiply those first. So if I FOIL, I get x squared. My outers are xc. My inners are cx. And my last times last is plus c squared. Now, if you look inside those parentheses, you actually have a pair of like terms. So when you go to combine those like terms, you're going to end up with x squared plus 2xc plus c squared. And I left a gap there because sometimes people don't see how it becomes 2xc. So just in case you don't see that, I'll just show you that we're using the commutative property of multiplication. So you see you have an xc and this is a cx. Well, this is c times x. Multiplication is commutative. So that was supposed to be a times right there. Let me get rid of it. Okay, so that's c times x. Since multiplication is commutative, you can switch the order. And now you can see a little more clearly that you have 1xc and 1xc, so that makes 2xc. Okay, now you get to distribute the 3. This really is a lot of algebra work. So those of you who enjoy algebra, you like this topic, and that's good news for you. And that's what f of x plus c is. Nothing else combined, so f of x plus c is these 4 terms. So I'm going to go in here and replace with 3x squared plus 6xc plus 3c squared minus 2. I'm going to distribute this negative to make it minus 3x squared to make it plus 2. And then if you've done this correctly, things should cancel and things should reduce. So go ahead and finish that problem. Okay. And in the end, you should end up with this. So this particular answer ends up with 2 different variables and 2 different numbers. If anyone out there is thinking, can I factor out a 3? You can, but there's no need to. And but you can't get rid of the 3. So if you're thinking like, oh, I'll factor out the 3 and get rid of it, you can't get rid of it. So if for some reason it makes you happy to factor out a 3, go for it, but you cannot delete or omit the 3. So that should be our final answer there. And just to make a quick note, the reason I like to show 2 steps here, because here what cancels is 3x squared and the 2's, and then what reduces is a c. And again, you have options here. If you want, what a lot of students usually prefer is, since this is a monomial denominator, or 1 term, you take the first term of the numerator, put it over the denominator, take the second term of the numerator, put it over the denominator, and then that'll reduce here. The c's will reduce, and then you'll end up with 3c here when 1 pair of c's reduces. But excuse me, what I wanted to mention was the reason I don't like you to do all the reducing and canceling all at once is because I want to make sure you're doing order of operations correctly. So if I take you back, okay, back to like here. I like to see this in 2 steps, because what needs to happen first is you need to cancel out the 3x squareds and the 2's and then reduce the c. So that's why I don't want you to go in here and then like reduce the c, because if you didn't have this step, if you just had this, I can't tell if you thought you could get rid of the c's first or if you canceled out those terms first. Okay, because anyone who's thinking, oh, I'm going to reduce these c's first, I call it illegal algebra. You can't do that. That's incorrect algebra. So that's why I like to see this as 2 steps. So go ahead and cancel out the 3x squareds and the minus 2's and rewrite it. Please humor me with that extra step, and then you can reduce. All right, and that concludes today's lesson. Rest assured you will get more practice on this tomorrow and opportunities to ask questions about it as well, because everybody's going to be in a different spot with this right now. Some people are very comfortable with the formula, actually kind of enjoying it, and some people are really thrown off by this part right here. Okay, so thanks, guys. I'll see you in class next time.